We're Indegene, and we deliver better outcomes through Atom.
Excellent. Good morning, everybody. It's a real pleasure to be here in London. As you can tell from my accent, I've got a slight British accent, but I'm actually Australian, so my accent might change as the panel goes through. So I'm really honoured and humbled to be here today to introduce this great panel of speakers. As Mark mentioned, I am head of medical writing at Pfizer, and so I have a keen interest in the area of AI and natural language uses, processing, generation in particular. So I'm really interested to hear what some of our speakers have to say today. And so what I will do is I'll introduce each one and have them come up and sit in these stools. And just sort of give you a very high-level introduction to each. So maybe I'll ask Philip to join us here on stage. Philip Maurer is the head of customer engineering for the public sector and life sciences, based here in London and working for Google. Christina Busmalis, who works for IBM and who is a director in the global life sciences business of IBM Watson Health. Tarun over here, Tarun Mathur, is the chief technology officer for Indegene. And Annette, if you could join on the end here, that would be great. Annette works at Microsoft and is a principal solutions specialist in the health team. So you can see that we have a great panel of folk here gathered today. I'm going to pose a few provocative questions to each of them. And we're going to go through a few elements, illustrate with examples, and have a very engaging discussion as a panel. We hope there'll be some time at the end for questions. But what I'm going to do is I'm going to pose my first question to you, Tarun. I want to sort of, as someone who working in the pharma industry and in life sciences, one of the things that I often find about AI is it can be a bit of a black box with all the algorithms under the hood. So maybe you can just scene set for us and give us an idea of the spectrum of AI and different strategies in AI. And Terry, maybe you can start us off, followed by Christina.
So the big picture view of AI and specifically machine learning as computational techniques to either augment or automate human SME tasks. I think that's something, by virtue of being at this event, we're all pretty familiar with. In terms of the black box, some of the areas that we're really interested in are things such as natural language processing, which you already heard mentioned, machine vision, speech to text, a lot of these technologies that are used in the unstructured to structured pipeline. So we love capitalizing on pre-trained models and some of the work that actually my peers on the panel have been involved in, or companies have been involved in. Going forward, what we're seeing is that there's really three levers we can pull. It's the hardware, the data, and the algorithms. And I think in the past few years, we've seen significant advances in all three, but I think the low-hanging fruit on the hardware side has been plucked, and we've seen that from NVIDIA and from Google. And I think on the data side, we've seen a lot of examples where there's massive corpuses of data have already been used to pre-train models. With OpenAI with their GPT-2, we've seen that was kind of controversial earlier this year. And so what I think going forward we're going to see is on the algorithm side, can we start getting algorithms that deal with sparse data, lower quality data, so we can unlock business use cases that we really have struggling now or restricted by the amount of data available. So the black box, in many ways, is kind of there in AI, but what we're looking for are algorithms that can be trained far more quickly and with closer to real-world data, especially in pharma. There are really big impact use cases where we know we can make a difference, but the data just isn't there. And so we're seeing, like in transfer learning, some big advantages there. Spatial evolutionary testing is another. There was a paper published last year that may have profound effects on being able to train machines effectively with smaller data sets. So we're really excited about that, and I think that will help push this envelope a lot further.
Excellent. Christina, do you want to add something to that from your perspective?
Yeah, sure. So I think, I agree with all of Tarun's points. As we move into, we need to get AI to be much more scalable, economical, and consumable. And you may have heard the term broad AI as we move forward. So there's a concept of narrow AI, which is taking a narrow slice of data and applying machine learning to it. Very powerful, very strong, but not scalable. And in IBM Research and IBM Watson Health, we are moving forward with what we call broad AI. Broad AI is the capability to take many different data points, so no longer narrow, but broad AI. If you think about our industry, that's things like omics data, imaging data, health records, all the claims data, social determinant data, your social media data, everything like that, a broad data set, and applying AI to that and being able to reason and learn together to speed up the process, as well as to be able to address the small data sets that Tarun's mentioned. By applying broad AI, it's no longer about big data, it's about broad data. And you can actually adjust your algorithms on the fly as your data changes, which is different than narrow AI, which is, again, hardcore data set. All of this will bring better time to value and time to market. Around transparency, that's a key a perspective of broad AI as well, where we want to actually be able to show the lineages of decisions made to remove that black box concept. And in IBM, we call that explainable AI.
Excellent, thank you. No, that's very enlightening, and I really appreciate the sort of the depth. So let's move from sort of some of those concepts and move into some real examples. And you see some statistics up on the back here that sort of AI is being deployed broadly. As a couple of you mentioned pharma, I know that sort of we have a keen interest in deploying that in many elements of our business. So what are some of the sort of something in the commercial space? In the commercial space, AI perhaps has made more inroads, and there are some really great examples already in our commercial space, I know, within our company and broadly. Can you maybe give a couple of examples or some examples from your perspective of successes in the commercial space? Christina, maybe start us off.
Yeah, great. So again, I hope I'm okay talking too fast for anyone of you, but from a commercial space, we're looking at really bringing drugs to market and actually keeping them in the market and making it sustainable. So really driving value from providers, payers, and ultimately patients in that space. And again, if you look at that area, there's a lot of areas that can actually benefit from AI, whether it's commercial effectiveness, value-based contracting, and really patient empowerment or digital therapeutics or precision medicine, all those different terms you hear out there. I'll just talk about two quick examples in the area of diabetes. And the underlying component of those, and actually even all those areas I talked about, is around real-world data. So using real-world data and applying machine learning to that. So one example is in the area of diabetes with Roche, that we developed a machine learning algorithm to be able to predict when someone has chronic early kidney disease or kidney failure when they become a diabetic 3 years in advance. And by understanding that patient stratification, you can actually target and apply that into commercial effectiveness. Another area, staying in the area of diabetes, is around patient engagement. So as a diabetic, which I'm sure someone in the room or many in the room are, you know that it's actually a disease you manage yourself. On average, 5 hours a year is spent with a healthcare practitioner. So basically, you need to manage your disease. You need to keep your glucose levels in that comfort zone. Don't go too high, don't go too low. And with Medtronic, we developed a mobile companion app called Sugar IQ, which actually helps a patient manage their disease by providing recommendations on what to do, what to eat. It takes a lot of different broad data, therapy events like your continuous glucose monitoring, your insulin data, what you're eating, takes in lifestyle, how you're sleeping, what sports, also what time of day, where you are, what's the weather like, and provide personalized recommendations. We were able to show, again, with machine learning, that we could actually predict when someone will have a hypoglycemic event 2 to 4 hours in advance with 89% accuracy, allowing people to adjust their lifestyle to reduce the risk of that happening.
Excellent. Tarun, maybe add something from your perspective.
Yes, I can talk about a use case within our organization is on the commercial, the marketing side. So we're dealing with issues around how do I scale up content production. So the entire content life cycle, developing content to address scalability across geographies, across different channel types, and the digital experience also, personalization demands are also a part of it. So something we've been looking very closely at is within our space, we have boundary conditions of med legal review, so there's a lot of content reuse and reusability going on. Can the machines look at content the same way a subject matter expert does, break it down into contextualized, useful, reusable components that are put into a taxonomy that's actually useful, and then reassemble content across the different channels and transforming it. So we've been able to demonstrate this across a variety of channels and have seen significant reductions in the time to get content out. One example we've actually done is 75% reduction in time to build email content, for example, with certain key messages that are in place. And we've seen this now broadening across. So that's another example where AI and natural language processing have a big impact.
Excellent. Thank you. Annette, did you want to just add something here as well?
Yeah, we've been really lucky at Microsoft. We've been working with the NHS and we've been collecting new streams of data. So we've been getting data from wearables and patient devices that are connected by Bluetooth. And we've been working quite close with COPD specialists and looking at how we can they can look at different models of care. But it's funny because we're talking about commercial. So who is the buyer in the NHS? Is it the doctor? Is it the system? Or is it the patient? But what's really interesting, I think, if we look at all those three parties that are involved, what we've seen, the feedback from the patients has been exceptional. They feel trust. They understand the data. They're working with the doctors on their data. And they understand what it means to have the wearable and be connected, and how that helps them in their care. So that's a really interesting dynamic that we've seen brought to the table, not just all on the technology side, because we know the algorithms are working really well, and we know how the nurses and the doctors are starting to interact and take this on board. So interesting perspective.
Excellent. So these are really interesting examples of in a commercial setting where we're looking perhaps at a content model and the ability to generate content using AI, natural language techniques. Christina, you highlighted the ability to sense from multiple sets of data in the diabetes area. And again, Annette, you spoke there about the hospital setting. So let's kind of switch gears. So AI probably has been a little bit more mature in that commercial setting. But as we move closer into a clinical setting, whether it's patient care or whether it's in clinical trials as we develop, what are some of the things that we can learn from that commercial setting to bring into the clinical setting? And what are some of the things that have to transform for us to be able to do that? And maybe, Philip, I'll ask you to lead off with some examples here.
Sure. So maybe starting with what needs to change. I think one of the key challenges in the clinical space is still data interoperability. So making sure that data sets, even within the same kind of trust, are actually accessible via the same means. Traditionally, people will have purchased different types of equipment, different times of the life cycle of the organization, and those will generate different formats of data. So just getting that sort of normalized so that you can feed it in an algorithm is meaningful. An example of what can be achieved once the data is accessible is a project we worked on with Moorfields Eye Hospital last year. So in conjunction with our colleagues at DeepMind, we developed an algorithm for detecting 50 different types of eye illness and also categorizing those into the appropriate level of severity. That's a really helpful approach because even experienced clinicians, and we tested the algorithm versus people that have done that kind of job for 10 plus years, people make mistakes, and having that second opinion of a diagnostic algorithm is extremely helpful to make sure that the patient gets the best possible outcome by having the right diagnostic at the start. I think the other thing that's interesting about that particular project is how we approach the black box challenge that was mentioned earlier. So the algorithm is actually based on two separate neural networks. The first neural network gives the clinician a three-dimensional view of the OCT scan and shows exactly what the AI detected, what it thinks is present. And then the second neural network takes the output from the first network and effectively provides a diagnostic, which is then what the clinician will use together with the patient. And crucially, each of those data points that are presented by the AI also come with percentage points so that the clinician actually knows how confident the AI itself is in performing that particular diagnostic.
Excellent, lovely. And Annette, did you want to add something beyond maybe developing that example that you gave a little bit earlier on COPD?
It's in the specific work that we did on COPD, how the algorithms are working. Mm-hmm. We've got a real sensitivity with the algorithms at Glasgow and Clyde that the nurses and the doctors are working on, and I think it's interesting as we get more data and as the machine starts to learn about the patients, their behaviours, and how the patients start to engage. I think it's going to be interesting too as our data scientists start testing these algorithms and seeing the sensitivity increase. But for me, it's always about the feedback loop to the users and the buyers and the patients and the doctors, because I think that's where we will start to see some scale going in all our examples and in everything that we're all working on.
Excellent. And Christina, did you have anything further that you wanted to sort of speak about in this example?
Yeah, and I'll move over to more clinical trial side of things from a pharmaceutical company. So really, again, bringing your drug through the phase 1 to phase 4 or phase 3. And I think we all know in the industry, the holy grail was how can we get to drugs to market faster and cheaper. It's been a promise for decades, right? And we're still not there. We still have a challenge of reaching that. If you think of clinical trials, 80% of them don't finish on time. 86% of them don't have enough patients to recruit. And if you look at the protocols that are created when you create a clinical trial, over 50% of them have to be amended. And every time you make an amendment, it costs $500,000 in 61 days. So something is quote unquote broken in that process. And it's a very sequential process if you go into clinical trials where you really have creating your protocol, throw it over the wall, find your sites, throw it over the wall, find your patients. And we believe that AI can really change how you drive clinical trials and have a better clinical trial transformation. So we'll start back at the protocol design area. Protocols include things like inclusion-exclusion criteria, your clinical endpoints. You can actually apply AI to help you build the right protocol using historical information of what protocols have worked before, as well as using, again, real-world data to identify what are the right inclusion-exclusion criteria that then can be applied into patient recruitment. By having the right protocol and optimizing the right protocol, you can move through clinical trials faster. You can also look at risk-based monitoring and site selection. So how can you actually determine which sites are the right sites to use, which investigators are the right ones to work with, again, based on applying machine learning into that area, and have a risk of potentially high-risk population sets and potential adverse events. So again, understanding all those areas ahead of time will help you drive into clinical trials. One example that we have actually is more on the point-of-care solution. So we have a solution called clinical trial matching, finding the right trial for a patient, which we know is a challenge. And we worked with Mayo Clinic to develop that solution. And since they've been using this solution for 18 months of applying NLP to understand inclusion and exclusion criteria as well as patient data, they've been able to increase 84% the amount of women to be for breast cancer to be on the right trial. Quite impactful from that perspective. And now we are flipping that to look at that from a pharma perspective. Find me the right patients for my trial versus find me the right trial for my patients.
Excellent. And Philip, I know you were speaking about the Moorfields example. Have you got anything that you'd like to sort of add again around sort of the clinical trial setting?
Yeah, so I think it's good to just try to break clinical trials into the individual components. And there's some very simple things that happen right at the start that can be automated and are in scope for automation now. So a very simple element that I'm thinking of is de-identification of data. Mm-hmm. So somebody else, potentially a hospital group, is going to run the clinical trial. Then when that data has been collected, it needs to be de-identified. All the personal identifiable information needs to be removed. And that then can be handed to, say, the pharma organization that actually asked for that trial to be conducted. That process today, in most parts of the world, is still highly manual. It still involves a lot of clinical practitioners picking up Sharpie pens and writing over people's names. It's error-prone as a result of that, but it's also not a very good use of that kind of expertise. You'd rather have those people actually performing, clinical work. So actually providing algorithms for that, and we have an off-the-shelf solution for that particular challenge, I think is something that can be utilized today and can make an impact in terms of accelerating clinical trials.
Excellent. So I think, and again, just to pull some of those pieces and strands together, you heard some real life examples already in deployment in either the full clinical setting or the clinical trial setting, whether it's through the data flow, the data acquisition and de-identification of data at point, and also from my perspective, as we disclose information and are more transparent with data sharing, that de-identification of subject data becomes even more important as so much more is in the public domain. And Christina, that example of protocols are near and dear to my heart. My group write all the protocols for Pfizer, so all of those numbers, I do hear, and it's great to know that we're moving in directions to utilize vast amounts of data to improve protocols up front. So really appreciated that example. So just kind of thinking about 2025. So as we think about where we are today, and some of these are real, they're in deployment in various stages and phases of deployment across different pharma, across different hospitals. 2025 may look very different from where we are now in 2019. And so what does the patient journey in 2025 look like in an era where AI really takes us into a different space? And maybe, Philip, I'll ask you to lead off with this one.
Sure. So, I mean, one observation I would have is that I think the patient journey is already changing quite significantly today. And, you know, here in the UK, a great example would be Babylon Health. I no longer have to start my journey as a patient by going to a GP's office as the first step necessarily. I might be able to just pick up the Babylon Health app, rely on the TensorFlow implementation they've used to route me to the right kind of specialist. And so I think we'll see more of that type of change happening as we move forward into the future. More kind of self-service experiences, but also more personalized towards me as a patient, based on the data that I'm willing to share with the service providers.
Excellent. No, that's great. And Christina. Sorry, I'm going to go down the line. It's easier with the microphone.
So I'm going to be a bit provocative and say whether it's 2025 or later, that depends, right? Because one of the things is technology is being developed, but it's always the change management process of bringing new technology in and impacting an industry. And we know the pharma industry, 6 years is not a very long time. So I'm going to keep the 2025 and put a little quotes around that. I also want to change the name patient to healthcare consumer, because actually we need to start thinking about the people prior to being sick and being actually provide them the right health as they go forward. So where do I see that going? And I'll go back to the view of broad AI, which I talked about earlier, is that we've already been working in evidence-based medicine for quite a while, predict the likelihood of something using artificial intelligence. We've also moved a bit into precision medicine, looking at molecular data, and being able to combine the two is quite impactful already. So having both broad data of patient records, broad data of genomic data. Shown examples of disease management. So actually, again, getting sensor information, an example of a COPD and diabetes, of being able to have a view of sensor information. So now you have a lot of broad data. But what we need to get to is actually preventative medicine. So not actually have prediction of where we're going, but prescription. Being able to prescribe on a very detailed healthcare consumer level of where their journey is going to be. Now, if we go back to 2025 a bit, and I go back into clinical trials, I think there we've actually we'll make quite an impact. I think we already will actually have optimized protocols. We will have streaming of data to improve patient-reported outcomes, be continuous, being much more accurate than they are today. We will have the patient being much more empowered to find their trials themselves and be part of that journey up front. So I think there's an area in the clinical trial that's transforming for 2025, but the bigger picture is getting towards preventative medicine because we cannot sustain the current model.
Excellent. And I know that, Tarun, you've got a couple of things to say, but Annette, I know you've actually got something, so maybe I'll have Annette speak and have you anchor for us, Tarun, if that's okay.
We're going bold. Yeah. We're going left field on this, and we want to really think about the patient having an immersive experience with the doctor. And what does that mean to the patient? How does that change their either how they're in a clinical trial, how they commit to clinical trials, or their actual journey with their doctor? And we're pushing quite hard with HoloLens, and we're doing a lot of work around pre-surgical planning, but also what's coming bigger and bigger is patients having that immersive experience around their image data, understanding the effects of drugs, understanding what surgery might mean for their own personal surgery, and having doctors map this out in a mixed reality environment. And you have to remember, with HoloLens and mixed reality, this is technology that has been in market for about 3 years in the UK clinically. So it's really early days, but we can see that becoming such a bigger situation, especially by 2025.
2025.
Yeah, incredibly.
Excellent. And Tarun, do you want to sort of bring it all together at the end and maybe highlight something, touch on these high points?
Yeah, so I'm really excited about all these techniques that we just heard about. And from our lens, we're really interested in capitalizing on these amazing advancements that are being done and bringing them to the pharma enterprise. How does that impact how pharma engages with their customers, whether it's the caregivers or the patients themselves. So I think there's going to be a change in the responsibility for pharma to be able to empower these tools, provide information to the patients, really improve that digital experience that everyone's expecting, right? These days, every consumer wants that Netflix and Amazon experience, regardless of who they're engaging with. I think pharma has a big role to play in there, and these technologies can really help bring that forward. So we're really excited to be a consumer and applier of the techniques we just heard about.
Excellent. Well, I'm very conscious it's very challenging to fit all of that into 25 minutes. So I realize that was probably dancing over the top of many different concepts for everybody. But we're very close to our time. So again, I just want to thank all the panelists for coming to London, for staying in London, and we're just walking down the street, Philip, for you, just to sort of share some of these insights and hopefully give you a real flavor of current state of the art now, state of early deployment, state of what's coming, and then really looking ahead to sort of broadening that digital experience for a patient, whether they are sort of in the general care setting or whether they're looking for a trial to become part of a clinical trial as part of their standard of care with the development of new medicines. And you can really see how companies are broaching this, and again, from a pharma perspective, how we're able to integrate that all into our medicines development experience. So I think we may have time maybe for one question, session chair. Maybe one question from the audience. Is there anybody who has a question that they would like to ask? Oh, you're taking a photo, not putting your hand up.
Thank you for a fascinating talk. I wonder about how you use AI to predict the future using historical data. So, for example, if you have a clinical trial site that wasn't performing so well previously, but then remove those barriers and blocks to their performance, how would AI not exclude that person, that site from the short list of who you approach? So the question is around using historical data to predict the future.
So, Christina, I know you spoke a little bit about RBM, but and risk-based monitoring. I think, speaking as someone, we do risk-based monitoring on an ongoing basis for studies. But as we're about to deploy studies, we also do quite an extensive analysis of prior site performance, and part of that would be looking at some of the reasons for the poor performance in the past. I will say there are some things that, so if it may have been around finding patients, that is a modifiable element. For sites that typically are not very GCP compliant, that doesn't tend to be a modifiable element and doesn't tend to be something that we may take another risk on. But maybe, Christina, you can answer from an algorithm perspective.
I think you've hit on that. I mean, if you look at machine learning, it typically is about it's creating statistical evidence, right, and being able to find patterns of information. So looking at a large set of historical information from clinical trials, you can pull out different patterns of information and be able to drive them, whether it's in neural networks or different designs. There's so many different types of machine learning models that can be used, but it's finding those recurrent patterns and learning based on that what happened to the outcome. So understanding, as you said, this site never found me patients, or it found patients 10% of the time. You can actually build models to understand of what is optimal and what is not optimal, and find the patients from that perspective. Do you want to add to that?
But I think
I can add a little bit to that.
At
least from our experience today, the way we're using AI in that space is actually more around the data mining, extracting it, normalizing it, transforming it, arming the data scientists. But the reality is, for us, there's still a human in the loop element. So we're able to structure the data, filter it, make some sense out of it, but it's still the human expertise. And we work closely with Pfizer and other experts to help do that, but it's still very much a human in the loop today. I think going forward, the role of the data scientist is starting to go down, right? There's more and more of that can be automated, but we don't feel that's ready yet today.
But I think it's a great question, because I think it speaks to elements of a model that need to adapt based on weighting of certain pieces and certain aspects of the pattern that goes into it. And certainly, that sort of, I think sometimes speaks to the complexity of scaling, certainly in a clinical setting as well. But it's a great question. Thank you. So I think we're at time. Again, I want to thank you for your attention. I want to thank my panelists who did a grand job and who actually, My job was to keep them on time, and I actually didn't have to do an awful lot of that. So thank you for good, concise, great illustrations full of examples. And we will be around, so if anybody does want to catch any of us around, please do. Thank you again, and thank you, panel.